In 1821, a French antiquarian named Sébastien Louis Saulnier paid a team of workers to cut a circular section of stone from the ceiling of a temple in Upper Egypt. They used saws, gunpowder, and chisels. The work took 22 days. When they were finished, they had removed a disc of sandstone roughly 8 feet across and perhaps a foot thick, weighing several tons. They lowered it through the roof they had destroyed, loaded it onto boats, and shipped it down the Nile, across the Mediterranean, and eventually to Paris, where it now hangs in a climate-controlled gallery of the Musée du Louvre, suspended on steel cables, lit from below by soft museum lighting that makes the carved figures seem to hover against the stone like something dreamed rather than made. The object is called the Dendera zodiac. It is the only complete map we possess of an ancient sky, and for 2 centuries it has refused to tell us when that sky existed. Stand beneath it in the Louvre today, and you will see the cosmos as someone once imagined it, or perhaps as someone once recorded it. 36 figures march around the outer rim, the decans, star groups that mark the passage of Egyptian hours through the night. Inside that ring, the 12 familiar signs of the zodiac wheel in procession: the ram, the bull, the twins, the crab, the lion, the virgin, the scales, the scorpion, the archer, the goat, the water-bearer, the fish. And scattered among them, rendered in the precise Egyptian style of raised relief, are the 5 wandering stars the ancients called planets: Mercury, Venus, Mars, Jupiter, Saturn, each positioned at specific points along the ecliptic, frozen in whatever configuration they held on the night this ceiling was meant to commemorate. The carving is exquisite, the astronomical detail is extraordinary, and the questions it raises have never been satisfactorily answered. When Napoleon scholars first examined the zodiac in the early 19th century, they believed they were looking at something impossibly ancient. The mathematician Joseph Fourier, who had accompanied the Egyptian expedition and would later become famous for his work on heat transfer, studied the planetary positions and concluded the ceiling depicted a sky from around 2500 BCE, more than 2,000 years before the temple that housed it was built. Other scholars pushed the date even further back, some arguing for configurations that would place the observation in the 3rd or 4th millennium before Christ. The implications were staggering. If correct, it meant the Egyptians had been practicing sophisticated positional astronomy at a time when, according to conventional history, they were only just beginning to unify the kingdoms of the Nile. The controversy that followed became known as the Dendera affair, and it consumed European intellectual circles for decades. Biblical literalists attacked the early dates because they conflicted with Archbishop Usher's calculation that the world had been created in 4004 BCE. Classicists defended them because they seemed to confirm Egypt's status as the mother of all sciences. Astronomers argued among themselves about the reliability of retrograde calculations over such vast spans of time. The dates proposed ranged wildly, from 2500 BCE to 147 CE, a spread of more than 2.5 millennia, which is another way of saying that no one really knew what they were looking at. Modern scholarship has largely settled the question of when the zodiac was carved. Sylvie Colville and Eric Aubour, working in the 1990s, conducted a meticulous examination of the planetary configuration and identified something the earlier scholars had missed. Eclipse markers. Hidden among the celestial figures, they found representations of 2 specific eclipses: a solar eclipse depicted by the goddess Isis holding a baboon, corresponding to March 7th, 51 BCE, and a lunar eclipse symbolized by the Eye of Horus, corresponding to September 25th, 52 BCE. The planetary positions, when calculated against these anchoring events, aligned precisely with a date around 50 BCE, so the mystery was solved. The zodiac was carved in the 1st century before Christ, during the late Ptolemaic period, probably to commemorate a specific astronomical event, or perhaps simply to adorn the ceiling of a chapel dedicated to Osiris. The Temple of Hathor at Dendera was expanded under the Roman Emperor Tiberius, and the Pronaos, the entrance hall where the zodiac was installed, dates to that era of Roman administration. Case closed. Except the case was never really closed, because even if we accept that the stone was carved around 50 BCE and the evidence for that date is compelling, we are still left with a deeper question that the dating controversy obscured. Where did the knowledge come from? The zodiac itself is not Egyptian. The 12-sign system that divides the ecliptic into equal segments of 30 degrees each originated in Babylon probably around the 5th century BCE. The Egyptians had their own astronomical traditions, centered on the rising of Sirius and the movements of the Decans, but the zodiac as depicted at Dendera is a foreign import, a Babylonian framework dressed in Egyptian iconography. This much is well established. The ceiling represents a syncretism, a blending of Mesopotamian mathematical astronomy with Egyptian religious symbolism filtered through the Greek intellectual culture that dominated Egypt after Alexander's conquest. But here is what troubles careful observers: the sophistication of the synthesis. The Dendera zodiac does not merely borrow the Babylonian zodiac signs, it integrates them seamlessly with the Egyptian decanal system, positioning the 36 decans around the rim in a way that maps precisely onto the 12 zodiacal divisions. It depicts the 5 planets not as abstract symbols but in specific positions that can be reverse calculated to actual dates. It includes representations of the celestial poles and the axes of the world. It is, in short, a working astronomical document, not a decorative flourish, but a genuine map of the heavens that encodes real observational data. And the question that has haunted astronomers since Fourier's time is simply this: how long did it take to develop the observational tradition that made such a map possible? Consider what is required. To place the planets accurately, you need centuries of recorded observations, not guesses, not myths, but systematic nightly records of where each wandering star appeared against the background of fixed stars. To calibrate the decans, you need generations of careful timekeeping, noting which star groups rose at which hours of which nights across the full cycle of the Egyptian year. To understand the precession of the equinoxes well enough to create a stable coordinate system, you need observations spanning not decades but centuries, perhaps millennia, because precession moves so slowly, about 1 degree every 72 years, that it would be nearly imperceptible within a single human lifetime. The Babylonians had such records. We know this because we have found them, thousands of clay tablets covered in cuneiform astronomical observations dating back to at least the 8th century BCE, and probably earlier. The Babylonians were obsessive record keepers, and their astronomical diaries, recording planetary positions night after night for hundreds of years, gave them the data foundation necessary for predictive astronomy. But the Egyptians left no such records, or rather, we have found none. The astronomical papyri that survive are fragmentary, late, and mostly concerned with the religious calendar rather than positional astronomy. The temple inscriptions tell us about the heliacal rising of Sirius and the orientation of sacred buildings, but they do not give us the kind of systematic observational data that would be needed to construct something like the Dendera zodiac from scratch. The conventional explanation is cultural transmission. The Egyptians borrowed the Babylonian system wholesale, probably during the Persian period when both cultures were united under Achaemenid rule, and later refined it under Greek influence during the Ptolemaic era. The zodiac at Dendera is therefore not evidence of indigenous Egyptian astronomical achievement, but rather a monument to successful knowledge transfer across cultures. This explanation is almost certainly correct as far as it goes, but it leaves something unexplained, a residue of strangeness that careful scholars have noted without being able to resolve. The astronomer John H. Rogers, writing about ancient star maps, called the Dendera zodiac the only complete map that we have of an ancient sky. He chose his words carefully. Not the oldest map, not the most accurate map, but the only complete one. Every other ancient astronomical document we possess is fragmentary. A list of stars here, a planetary observation there, a mythological account of celestial events that may or may not encode real data. The Dendera zodiac alone gives us the whole picture: fixed stars, wandering planets, coordinate systems and temporal markers, all integrated into a single coherent representation. And the question that haunts the edge of the scholarship is whether such completeness could really have emerged from the patchy, derivative astronomical tradition that the surviving Egyptian sources suggest, or whether the ceiling at Dendera preserves something older, not necessarily carved older, but conceptually older, a copy of a copy of a copy stretching back into a past we cannot see. We will return to this question. But first we must travel north, 2,000 miles and 1,500 years, to a hilltop in central Germany, where a different kind of sky map waited in the earth for 3,500 years, and where the same impossible questions would emerge from the soil like something that had been buried alive. The men who found the Nebra sky disk were criminals. This matters because it means we will never know exactly how it lay in the ground, what surrounded it, What context might have helped us understand it? They came to the Mittelberg Hill in the summer of 1999, two treasure hunters with metal detectors operating illegally on protected archaeological land in the German state of Saxony-Anhalt. When their machine signalled something beneath the surface, they dug carelessly, damaging what they found with their spades, destroying the stratigraphy that might have told us everything. What they pulled from the earth was a bronze disc about 12.5 inches across, covered in green patina, inlaid with gold symbols that gleamed even through the corrosion of millennia. They did not know what they had found. They sold it, along with 2 bronze swords, 2 axes, a chisel, and fragments of spiral bracelets, to a dealer in Cologne. The disc passed through several hands over the next 3 years, its price rising as word spread through the underground antiquities market that something extraordinary had surfaced. By the time Swiss police recovered it in a sting operation in 2002, it had been offered for sale for nearly 1 million Deutsche Marks. The authorities returned it to Germany, where it now resides in the State Museum of Prehistory in Halle. And there, cleaned and conserved, it has become one of the most studied and most troubling objects in European archaeology. The disc is made of bronze, an alloy of copper and tin cast and then hammered to its final shape. The metal came from the Alps, specifically from mines in what is now Austria. The gold came from Cornwall, or possibly from the Carpathian Mountains. The sourcing is still debated. The tin in the bronze also likely came from Cornwall, which means that whoever made this disc was connected to trade networks spanning thousands of miles, from the Atlantic coast of Britain to the heart of Central Europe. This alone is remarkable. The disc dates to approximately 1600 BCE, possibly as early as 1800 BCE, based on the typology of the weapons found with it and radiocarbon dating of birch bark preserved in the sword hilts. At that time, Central Europe was home to the Unetis culture, a Bronze Age society known primarily from its burial mounds and metalwork. The Unetis people left no writing, no monumental architecture, no cities. They were farmers and herders, organised into chiefdoms or perhaps small kingdoms, living in wooden longhouses in a landscape of forests and rivers. They made beautiful objects, spiral arm rings, decorated axes, amber beads, but nothing in the archaeological record suggests they were astronomers. And yet someone among them created this disc. Look at it closely. Against the dark bronze background, now greenish-black with age, the gold inlays depict a cosmos. There is a large circle that may represent the sun or the full moon. Scholars disagree. There is a crescent that clearly represents a lunar phase. There is a cluster of 7 dots arranged in a tight group, almost universally interpreted as the Pleiades, the star cluster that has been recognised and named by virtually every human culture that has looked at the night sky. Scattered across the disk are additional dots, perhaps 23 of them, that may represent other stars or may be purely decorative. We cannot be certain. But the most significant features are the 2 arcs along the edges of the disk, one on each side. These arcs span about 82 degrees each, and their placement is not arbitrary. They mark the angle between the positions of sunrise at the summer and winter solstices, as seen from the latitude of the Mittelberg Hill, approximately 51 degrees north. This requires a moment of explanation. The sun does not rise in the same place every day. In summer, it rises far to the north of east, in winter, far to the south. The exact positions depend on your latitude. At the equator, the difference is minimal. As you move toward the poles, the swing becomes more dramatic. At the latitude of Nebra, the summer solstice sunrise and the winter solstice sunrise are separated by about 82 degrees of horizon, exactly the angle encoded in the golden arcs. Moreover, the orientation of the disk, if placed on the Mittelberg Hill, with the arcs aligned to the horizon, would have allowed an observer to track the solstices with precision, and the hill itself is positioned such that the sun appears to set behind the Brocken, the highest peak of the Harz Mountains, some 50 miles to the northwest, on the summer solstice. This is not coincidence. The Mittelberg was chosen as an observation site, and the disk was created as a tool, or perhaps a teaching device, or a sacred object, that encoded the astronomical knowledge gained from that site. Now consider what this implies. To determine the solstice angles with the precision shown on the disk, you need more than casual observation. You need a fixed observation point, used consistently over many years. You need a method of marking the horizon positions of sunrise, perhaps wooden posts, perhaps stones, perhaps notches carved into trees. You need a way of recording those positions and comparing them year after year, because the solstices do not announce themselves. They must be identified through the gradual reversal of the sun's drift along the horizon. You need, in short, an observatory and a tradition of systematic observation, extending over decades at minimum, probably generations. And you need a way of transferring that knowledge onto a portable medium, of abstracting the three-dimensional experience of watching the sky from a specific hilltop into a two-dimensional representation that could be carried elsewhere, shown to others, perhaps used to establish new observation sites with the same celestial alignments. The Unitas culture left no evidence of any of this. No observatory structures have been found, no recording systems, no astronomical texts, obviously, since they had no writing. No mathematical notation that might have allowed them to calculate angles or predict celestial events. The disk appears in the archaeological record like a message in a bottle, perfectly formed, technically sophisticated, and completely without context. Some scholars have suggested that the disk represents the culmination of a long Bronze Age astronomical tradition that left no other traces simply because it was conducted with perishable materials. Wooden posts, leather scrolls, oral transmission. This is possible. Absence of evidence is not evidence of absence. But it requires us to accept that a culture capable of creating one of the most sophisticated astronomical instruments of the ancient world left absolutely no other sign of that capability, not in any of the hundreds of Unitas sites that have been excavated, not in any of the thousands of artifacts that have been recovered. Others have suggested that the disk was not made locally at all, that it was an import perhaps from the Mediterranean world, where more advanced astronomical traditions existed. But the metalwork is distinctly Central European. The bronze composition matches local sources. The gold inlay technique is consistent with Unitas craftsmanship. Whoever made this disc was working within the material culture of Bronze Age Germany, even if the knowledge it encodes came from somewhere else. And this is where the disc becomes genuinely disturbing, in the way that certain unsolved problems are disturbing. Because if the astronomical knowledge was imported, we must ask, from where? The Babylonians had sophisticated astronomy by this period, but there is no evidence of contact between Mesopotamia and Central Europe in the early 2nd millennium BCE. The Egyptians were building their astronomical ceilings, but Egypt too was far beyond the Unitas trade networks. The Minoans on Crete had a flourishing civilization with possible astronomical interests. But again, no direct connection to the peoples of the German forests has been established. The disc sits in its museum case in Halle, and it does not explain itself. It simply exists. A bronze mirror reflecting a sky that someone watched with extraordinary care 36 centuries ago, using methods we cannot reconstruct, for purposes we can only guess at. The detectorists who found it damaged it with their spades. They destroyed the site context. They scattered the associated finds and sold them separately. We will never recover what they took from us in their carelessness. But perhaps the most important thing they took was the answer to a question we did not know we needed to ask. What else was buried with the disc? What other objects? What other records? What other pieces of a puzzle we cannot now assemble? The disc that fell out of the Bronze Age remains exactly that, something that fell from a context we cannot see into a present that cannot explain it. South of the Nile's Great Bend, where the river curves through the desert hills of Upper Egypt, the cliffs at Deir el-Bahri rise in a natural amphitheatre of pale limestone. It is one of the most sacred landscapes in Egypt, a place where the living and the dead have met for 4,000 years. The mortuary temple of Hatshepsut, Egypt's most successful female pharaoh, stands here, its colonnaded terraces climbing the cliff face in a geometry so pure it seems more carved than built. And beneath the temple, hidden in the rock, lies a tomb that should not exist. Tomb TT 353 belonged to a man named Senenmut. He was not royal. He was not, as far as we know, of noble birth. Yet he rose to become one of the most powerful officials in Egyptian history, accumulating titles that suggest an authority second only to the pharaoh herself: steward of the god's wife, steward of the king's daughter, overseer of the works of Amun, chief steward of the king. He was Hatshepsut's architect, her administrator, possibly her lover. The ancient sources are discreet, but the intimacy of their professional relationship is unmistakable. He designed her mortuary temple, he raised her daughter, and when he died sometime around 1458 BCE, He was buried in a tomb whose ceiling depicts a sky that has puzzled astronomers for over a century. The ceiling is the earliest known astronomical ceiling in Egypt. This alone makes it significant. But what makes it extraordinary, what makes it, in some ways, more troubling than the Dendera zodiac or the Nebra sky disk, is what it shows and how it shows it. The ceiling is divided into two panels, northern and southern, representing the two halves of the Egyptian sky. The northern panel is relatively straightforward, depicting circumpolar constellations and decanal stars in patterns consistent with other Egyptian astronomical sources. But the southern panel is wrong, not subtly wrong, dramatically wrong. The constellations depicted in the southern panel, Orion, the most conspicuous constellation of the southern sky, and Canis Major with its brilliant star Sirius, are reversed. They appear to be moving eastward, which is to say, in the opposite direction from their actual motion across the sky. This is not a minor error. This is not the kind of mistake a careful observer could make. It is as if someone had taken a map of the sky and printed it backward, like a mirror image. Archaeologists and astronomers have proposed various explanations. Perhaps the reversal was intentional, carrying some religious or symbolic significance we no longer understand. Perhaps it was a copying error, made when the design was transferred from a papyrus draft to the stone ceiling. Perhaps the craftsmen who carved the ceiling were working from a template they did not understand, reproducing shapes without knowing what they represented. The Spanish astronomer Juan Antonio Belmonte, who has spent decades studying Egyptian archaeastronomy, proposed an explanation that is both elegant and deeply unsettling. He suggested that the astronomical ceiling of Senenmut's tomb is a gigantic copy of a papyrus draft of a celestial diagram that would have existed and used to be represented in clepsydra, water clocks used for timekeeping in Egyptian temples. In other words, the ceiling is not a direct observation of the sky. It is a copy of a copy, a reproduction of a document that was itself a reproduction of something else. This would explain the reversal. If the original papyrus was meant to be viewed from below, as a ceiling would be, then a copyist working on a flat surface might have reproduced it, without correcting for the change in orientation. The error would then have been transferred to the stone ceiling, where it remains to this day. But Belmonte's explanation raises as many questions as it answers, because if the ceiling is a copy of an older document, we must ask, how old, and from where? The southern panel of Senenmut's ceiling depicts not only reversed constellations, but also specific stars and planetary positions. Jupiter, Saturn, Mercury and Venus are all represented, placed in specific locations relative to the fixed stars. The decanal stars of the southern sky are arranged in sequences that can be compared to other Egyptian astronomical sources, and here is where the strangeness deepens. Some scholars have noted that portions of the chart appear to record stars from the southern celestial hemisphere that would not have been visible from Thebes. This is a technical point, but it matters enormously. The visibility of stars depends on your latitude. From Thebes, at about 25 degrees north latitude, an observer can see stars down to about 65 degrees south declination, everything above the southern horizon during the course of a year. Stars further south than that never rise above the horizon, and cannot be observed no matter how long you watch. If Senenmut's ceiling includes stars below this visibility threshold, it means one of two things. Either the ancient Egyptians had access to observations made from somewhere much further south, perhaps from the upper reaches of the Nile, perhaps from the Horn of Africa, perhaps from somewhere else entirely, or the ceiling is based on a source document that did not originate in Egypt at all. There is a third possibility, of course. The identifications might be wrong. The stars in question might be misinterpreted, or the ceiling might be more symbolic than literal, depicting a mythological sky rather than an observed one. Scholarly opinion varies, and the evidence is not conclusive, but consider the context. Senenmut was not a minor official. He was the most powerful non-royal figure in Egypt during one of its most prosperous periods. He had access to every resource the Egyptian state could provide: the best craftsmen, the finest materials, the accumulated knowledge of the temple archives. If anyone in Egypt could have commissioned an accurate astronomical ceiling, it was Senenmut. And if anyone would have noticed that the ceiling was wrong, that the constellations were reversed, that the stars were misplaced, it would have been the priests and astronomers who used the tomb for ritual purposes, and yet the ceiling remains as it was carved. There is evidence that changes and adjustments were made to the ceiling art during its creation. Corrections were made, details were refined, but the reversed orientation was not addressed. Either the error was not recognized, or it was not considered an error at all. This is what makes Senenmut's sealing so haunting. It is not simply an ancient astronomical document, it is evidence of a transmission. Knowledge passing from one source to another through channels we cannot trace, with losses and distortions we cannot measure. Somewhere in the chain, something was reversed. Somewhere in the chain, stars that could not be seen from Egypt were included. Somewhere in the chain, the original observation, whatever it was, whenever it was made, wherever it was made, became separated from its context and transformed into something else. The sealing does not tell us where the knowledge came from. It only tells us that it came from somewhere. Senenmut's tomb was never finished. The burial chamber was carved but never decorated. The sarcophagus was smashed, perhaps deliberately, perhaps by tomb robbers. Senenmut himself may never have been buried there. His mummy has never been found. Toward the end of Hatshepsut's reign, or perhaps shortly after her death, someone systematically defaced his monuments, erasing his name and image from the walls he'd built. We do not know why, we do not know by whom. We only know that the most powerful official in Egypt fell from grace so completely that even his memory was targeted for destruction. But they did not destroy the ceiling. Perhaps they could not reach it. Perhaps they did not care about the stars. Perhaps they did not understand what they were looking at, and so the ceiling remains, in the darkness of a tomb that was never used, depicting a sky that may never have existed, at least not as seen from Egypt, not as seen from anywhere we can identify. It is a document without a source, a map without a territory, an answer to a question we have not yet learned how to ask. 3 objects now. A zodiac carved in Roman Egypt that encodes Babylonian knowledge of uncertain antiquity. A bronze disc from Bronze Age Germany that demonstrates astronomical sophistication without any supporting infrastructure. A tomb ceiling from New Kingdom Egypt that appears to copy a source document depicting stars invisible from the latitude where it was made. Each object is extraordinary on its own. Together they begin to form a pattern. Not a pattern of answers, but a pattern of questions. The same questions recurring across cultures and millennia. Where did this knowledge come from? How was it transmitted? And why does it appear fully formed without the centuries of developmental evidence we would expect to find? The conventional explanations, cultural diffusion, lost traditions, copying errors, are not wrong, exactly. They are simply insufficient. They explain the mechanism without explaining the origin. They tell us how knowledge might have moved from place to place, without telling us where it started, or why it took the forms it did. In the hours ahead, we will encounter more objects, more questions, more evidence of astronomical knowledge that appeared, functioned, and vanished without leaving the traces we would expect. We will travel east along the Silk Road to a cave in the Gobi Desert, where a star chart was painted on silk 1,000 years ago, depicting a sky with impossible precision. We will travel north to a circular enclosure in Germany that predates Stonehenge by centuries, oriented to celestial events its builders should not have been able to predict. We will confront what scholars have called the convergence problem, the troubling fact that multiple ancient cultures, separated by thousands of miles and thousands of years, developed astronomical systems that are not merely similar but mathematically equivalent, as if they were all working from the same underlying source. And we will end with the long silence, the centuries and millennia during which this knowledge existed, was used, was transmitted, and then disappeared, leaving behind only these scattered artifacts, these ceiling reliefs and tomb charts, and stone-carved sky diagrams, like messages from a civilization that knew things we have forgotten how to know. But that is ahead. For now, stay with these 3 objects: the Dendera zodiac in its museum case in Paris, the Nebra sky disk in its climate-controlled display in Halle, the ceiling of Senenmut's tomb in the darkness beneath the cliffs of Deir el-Bahri. Each one is a window into a sky that someone watched with extraordinary care, using methods we cannot fully reconstruct, for purposes we can only partially understand. Each one preserves knowledge that should have left more traces than it did. Each one asks us to consider the possibility that the history of human understanding is not the smooth upward curve we like to imagine, that there were peaks and valleys, advances and retreats, things learned and things lost. The night sky has not changed in any meaningful way since these objects were made. The same stars wheel overhead. The same planets wander through the zodiac. The same moon waxes and wanes. The cosmos is patient. It keeps its own records, written in light that takes years or centuries or millennia to reach us. But the people who watched that sky, who tracked those movements, who encoded their observations in stone and bronze and painted plaster, they are gone. Their methods are gone. Their reasons are gone. All that remains are these objects, these beautiful and troubling objects waiting in their museums and their tombs for someone to understand what they were trying to say. The ceiling that should not exist, the disk that fell out of the Bronze Age, the astronomer who drew stars he could not see. The prosecution has presented its first 3 exhibits. The case is only beginning. The Silk Road did not carry only silk. Long before the caravans bore their bundles of woven fabric across the mountain passes and desert wastes, long before merchants haggled over jade and spices and medicines in the oasis towns, something else moved along those ancient routes. Ideas, techniques, ways of seeing the world that had no weight and left no customs records but travelled farther and lasted longer than any bolt of cloth. And in one of those oasis towns, at the edge of the Taklamakan desert where the trade routes converged before plunging westward toward Persia and Rome, someone sat down in the late 7th century of the Common Era and painted a map of the sky, Dunhuang. The name means blazing beacon in Chinese, and for centuries it served as exactly that, a point of light in the darkness of the Gobi, a way station where travellers could rest and resupply before attempting the most treacherous legs of the overland journey. But Dunhuang was more than a caravanserai. Carved into the cliff southeast of the town in a honeycomb of caves that would eventually number in the hundreds, Buddhist monks had been creating one of the greatest repositories of human knowledge the ancient world would ever see. The Mogao Grottos, the caves of the 1,000 Buddhas, a library written on silk and paper and painted on stone, accumulating slowly over 9 centuries of devotion and scholarship. And then, sometime around the year 1000 CE, someone sealed one of those caves shut. Cave 17 was small, a mere adjunct to the larger Cave 16, probably used as a memorial chapel for a deceased monk. But before it was sealed, someone filled it with manuscripts, tens of thousands of them, scrolls and codices and painted banners, documents in Chinese and Tibetan and Sanskrit and Sogdian, and languages that scholars would struggle to identify for decades. Why were they hidden? Against what threat? By whose authority? The questions have never been satisfactorily answered. Perhaps it was an act of preservation against some anticipated invasion. Perhaps it was simply storage, a house cleaning of old documents that had accumulated beyond the capacity of the working library. Whatever the reason, the cave was plastered over, painted with a mural, and forgotten. For 900 years, it remained sealed. The man who found it was not looking for astronomical charts. Aurel Stein was a Hungarian-born British archaeologist, one of the great scholarly adventurers of the early 20th century, and in 1907 he was in Dunhuang following rumours of an extraordinary manuscript discovery. A Taoist monk named Wang Yuanlu had taken it upon himself to restore the deteriorating cave temples, and in the process of his repairs, he had accidentally broken through the wall of Cave 16 and discovered the hidden chamber beyond. What Wang found there staggered him. A room packed floor to ceiling with ancient documents, more manuscripts than he could count or comprehend. He had been selling them off piecemeal to fund his restoration work, and word had reached the scholarly community that something remarkable was emerging from the Gobi. Stein arrived in March of 1907. What he found in Cave 17 would take him months to sort through, and decades for scholars to fully catalogue. More than 40,000 manuscripts, the largest single cache of medieval documents ever discovered. Among them were sutras and poems and official records and commercial contracts and personal letters and medical treatises and astronomical calculations. And somewhere in that vast trove, preserved on a scroll of fine paper roughly 13 feet long, was a star chart unlike anything Stein had ever seen. It was not immediately recognised for what it was. The scroll was packed up with thousands of others, shipped back to the British Library in London, catalogued under the decidedly unpoetic designation OR A210 S3326, and filed away. The Dunhuang collection was simply too vast, too various, too overwhelming for any single scholar to comprehend. It would take nearly a century before the Star Atlas received the detailed study it deserved. When that study finally came, what scholars found was remarkable, The chart dates to the early Tang dynasty, somewhere between 649 and 684 CE, a period of extraordinary cultural flourishing in China, when the empire stretched from Korea to Central Asia, and the capital at Chang'an was arguably the largest and most cosmopolitan city on Earth. The atlas itself is organized into 13 panels. 12 of these panels depict the constellations visible from the equator, arranged in order from east to west as they would appear to an observer watching the night sky wheel overhead. The 13th panel is different, a circular diagram showing the north circumpolar region, the stars that never set, the fixed point around which the entire heavens appear to rotate. The precision is startling. 1,339 individual stars are plotted across those 13 panels, gathered into 257 asterisms, the Chinese system of stellar groupings that differs from the Western constellations but serves the same purpose, dividing the sky into recognizable regions that can be named and tracked and used for navigation and timekeeping. Modern analysis has confirmed that the brightest stars are positioned with an accuracy of between 1.5 to 4 degrees, close enough that an observer using the chart could locate them in the actual sky with confidence, but it is the cartographic technique that truly sets the Dunhuang Atlas apart. The 12-hour angle maps use what modern scholars describe as a quasi-cylindrical projection, a method of translating the curved surface of the celestial sphere onto a flat medium that preserves the spatial relationships between stars while minimizing the distortion that inevitably occurs when you try to represent a sphere on a plane. The circumpolar chart uses an azimuthal projection, viewing the sky as if from directly above the North Pole. These are sophisticated mathematical techniques. In European cartography, the formalization of such methods is typically credited to Gerardus Mercator, whose famous world map of 1569 used a cylindrical projection that became the standard for navigation. The Dunhuang chart preceded Mercator by 900 years. Chinese scholars have suggested that the atlas may have been drawn by a man named Li Chunfeng, a polymath who served as the head of the Imperial Astronomical Bureau under the Tang emperors Taizong and Gaozong. Li Chunfeng was one of the great scientific minds of his age, a mathematician, astronomer and historian who compiled star catalogues, wrote treatises on divination and calendar reform, and helped standardize the mathematical education of imperial officials. If anyone in Tang China was capable of producing an atlas of such precision, it was Li Chunfeng. But here is the difficulty. Even if we accept Li Chunfeng as the chart's creator, and this attribution remains uncertain, we have only pushed the question back one step. Li Chunfeng did not develop his methods in isolation. He was building on centuries of prior Chinese astronomical observation, drawing on records and techniques that had been accumulating since at least the Han Dynasty, and possibly earlier. The precision of the Dunhuang chart implies instrumentation, armillary spheres, sighting tubes, graduated circles for measuring angles, and it implies records, generations of observations compiled and cross-checked and refined, until the positions of more than 1,000 stars could be plotted with degree-level accuracy. Where are those records? Where are the intermediate documents, the working papers, the observational logs that would show us the process by which this precision was achieved? The Dunhuang cave contained 40,000 manuscripts, and yet among all that wealth of documentation, the Star Atlas stands curiously alone. We have the final product. We do not have the curriculum that produced it. The chart sat in the British Library for over a century, studied but not fully appreciated, its significance obscured by the sheer volume of material recovered from Cave 17. It was not until the early 21st century that detailed photographic and computer analysis allowed scholars to fully assess its accuracy and sophistication. What they found was a document that seemed to encode knowledge far older than itself, a 7th century copy of observations that must have accumulated over centuries, perhaps millennia, using methods that were never fully described in any surviving Chinese text. Who taught the copyist? Where are their notes? The question echoes, and now we must travel back in time, far back, far further than the Tang dynasty caravans or the Ptolemaic star temples or even the Bronze Age metalworkers of Central Europe. We must travel to a place where writing did not yet exist, where history as we understand it had not yet begun, where the very concept of recording knowledge for future generations had not yet been invented. We must travel to Goseck, the Burgenlandkreis district of Saxony-Anhalt, in the eastern part of modern Germany. a landscape of rolling farmland, small villages and rivers that have flowed through the same channels since the glaciers retreated. Unremarkable terrain, the kind of place you drive through without stopping, wheat fields and forests and the occasional church steeple breaking the horizon. Nothing to suggest that this land was once the site of one of the most sophisticated astronomical installations of the ancient world. In 1991, a man named Otto Brasch was flying an aerial survey mission over the region. Brasch was a photographer and amateur archaeologist, part of a long tradition of European scholars who had learned that the past often reveals itself from above, that buried structures alter the growth patterns of crops, creating subtle colour variations visible from aircraft but invisible to observers on the ground. These crop marks had led to the discovery of countless archaeological sites across Europe, from Roman villas to Iron Age hill forts to Neolithic burial mounds. What Brasch saw in the wheat fields near the village of Gozek was a series of concentric circular ridges, barely visible in the ripening grain, approximately 75 metres in diameter. He photographed it and filed the images. A decade later, in 2002, archaeologists François Bertham and Peter Biel began a major excavation. What they uncovered changed our understanding of Neolithic Europe. The structure they revealed had been built around 4900 BCE, nearly 7,000 years ago, when the entire region was populated by small farming communities that had only recently transitioned from hunting and gathering to settled agriculture. These were the people archaeologists call the linear pottery culture, named for the distinctive decorative patterns on their ceramic vessels. They left no written records. They built no great cities. They had no metals, no wheels, no plough agriculture. By any conventional measure, they were simple subsistence farmers, eking out a living from the newly cleared forests of Central Europe, and yet they built Gozek. The structure consisted of a circular ditch, roughly 75 metres across, surrounded by two concentric wooden palisade walls. The walls were not continuous. They were punctuated by gates, openings in the wooden barriers that allowed access to the interior. Most of these gates were positioned at cardinal points and other significant locations. But two gates in particular caught the archaeologists' attention. The southeast gate and the southwest gate were positioned with extraordinary precision. When archaeoastronomer Wolfhard Schlosser analysed their orientations, he found that they framed exactly the points on the horizon where the sun rises and sets on the winter solstice, the shortest day of the year, when the sun reaches its southernmost point and begins its slow return northward. The alignment was not approximate. It was not close enough. It was exact within the margin of error of the excavation measurements. Consider what this means. The winter solstice is not an obvious phenomenon. It is not like the full moon, which anyone can observe simply by looking up. The solstice is a limit, a turning point, the moment when the sun's daily path across the sky stops moving southward and begins moving north again. To identify it precisely, you cannot simply watch the sunrise on a single day. You must watch the sunrise for months, tracking its slow migration along the horizon, noting where it appears each morning, waiting for the day when it stops moving and reverses direction. You must do this year after year, accounting for variations in weather and local topography, building up a data set that allows you to predict with confidence exactly where the sun will rise on the shortest day. Then you must translate that knowledge into architecture. You must lay out a circular structure, dig a ditch, cut and transport and erect more than 1,600 oak poles, each 2.5 meters high, and position two gates so that they frame the precise points on the horizon that you have identified through years of careful observation. This is not something that can be done by a single observer in a single lifetime. The precision of Gozek implies multi-generational observation, decades or centuries of systematic skywatching, with some method of recording and transmitting the accumulated data from one generation to the next. It implies a social structure capable of organising the labour necessary to build such a monument. It implies a reason for doing so, some purpose important enough to justify the enormous investment of time and effort. And it was built 3,000 years before anyone invented writing. The excavators found evidence that the site had remained in use for roughly 2 centuries, from around 4900 to 4700 BCE. Within the enclosure, they discovered the remains of ritual fires, animal bones, and, disturbingly, human bones as well, including a headless skeleton near the southeastern gate. Whatever purpose the circle served, it was not merely astronomical. It was woven into the religious and social fabric of the community that built it, a place where the movements of the heavens intersected with the concerns of the living and the dead. When archaeologists and state officials reconstructed the wooden palisade in 2005, they used 1,675 oak poles to recreate the inner ring. The site was opened to the public on December 20th of that year, the winter solstice, the day that the structure was designed to mark. On that morning, for the first time in nearly 7 millennia, the sun rose through the southeastern gate exactly as the builders had intended. Göbekli is older than Stonehenge by at least 2,000 years. It is older than the pyramids of Egypt by more than 2,000 years. It is older than the oldest cities of Mesopotamia by nearly 2,000 years, and yet its builders possessed astronomical knowledge precise enough to encode solar positions in architecture, to create a structure that would function as a calendar and a ritual space for generations. How did they know? What methods did they use? Where did they learn them? What happened to that knowledge when the circle fell out of use around 4700 BCE? The questions multiply. And now we have 5 objects before us: the Dendera zodiac, the Nebra sky disk, the ceiling of Senenmut's tomb, the Dunhuang star atlas, and the Göbekli circle. 5 artifacts spanning more than 5,000 years of human history, scattered across 3 continents, created by cultures that had no direct contact with one another, using technologies that range from painted plaster to hammered gold to carved timber. And yet they share something that the explanations of cultural diffusion and parallel development and coincidental similarity struggle to account for. They share a way of seeing the sky. Consider the Pleiades, that tight cluster of stars in the shoulder of Taurus, visible to the naked eye as a faint luminous smudge on clear nights, resolving into 6 or 7 distinct points for observers with good vision. The Pleiades have been recognized and named by virtually every human culture that has left records of its astronomical knowledge. But more than recognition, certain cultures use them in the same way, as a marker of seasonal change, a clock in the sky that announced the proper time for planting or harvesting, or beginning a sea voyage. On the Nebra disk, the 7 gold dots near the crescent have been interpreted by scholars as the Pleiades cluster. The disk's 2 golden arcs mark the solstice angles at the latitude of the find site. Together, these features suggest that the disk was a tool for tracking the solar year, with the Pleiades serving as a celestial reference point. At the latitude of Central Europe, the Pleiades disappear below the horizon for approximately 40 days each spring, reappearing in the dawn sky in early June. Their return was a signal that summer had truly begun. The Dendera zodiac, carved more than 1,500 years later, and 3,000 kilometers to the south, likewise encodes the Pleiades. They appear in their traditional position in Taurus, integrated into a system of 36 decans that divided the night into hours and the year into seasons. The Egyptian agricultural calendar was tied to the annual flooding of the Nile, which was heralded by the heliacal rising of Sirius in early summer. But the decans, of which the Pleiades formed a part, served a different function, tracking the slow rotation of the stars through the night, measuring time by the procession of stellar groups across the sky. 2 cultures, 2 artifacts, separated by 1.5 millennia and half a continent, both using the Pleiades as a calendrical anchor, a fixed point against which the movements of the sun and moon could be measured. This is the convergence problem. The conventional explanation is independent invention. Human beings everywhere observe the same sky, face the same agricultural challenges, develop the same need to track the seasons. It should not surprise us that different cultures arrived at similar solutions. The Pleiades are a conspicuous asterism, easily recognizable, conveniently positioned near the ecliptic where the sun and moon and planets travel. Of course, multiple cultures would notice them. Of course, they would incorporate them into their astronomical systems. And yet, the specificity of the similarities troubles this explanation. It is not merely that multiple cultures noticed the Pleiades, it is that they used them in functionally equivalent ways, as components of larger systems that share deep structural similarities. The solstice alignments of the Nebra disk mirror the solstice alignments of Göbekli, though the disk is portable bronze and the circle is monumental timber, and they are separated by more than 3,000 years. The decanal system of Dendera echoes the asterism system of Dunhuang, though one is Egyptian and the other Chinese, and they are products of utterly different cultural traditions. The reversed southern sky on Senenmut's ceiling depicts stars that should be invisible from Thebes, just as the Nebra disk encodes solstice angles for a latitude where the metalwork was forged, both implying sources of knowledge external to the cultures that produced the artifacts. What are the odds that all of this is coincidence? The Earth's axial tilt, the angle between our planet's rotational axis and the plane of its orbit around the Sun, is approximately 23.5 degrees. This tilt is what creates the seasons. It is why the Sun rises further north in summer and further south in winter. It is why the solstices exist at all. Any culture sophisticated enough to track solstice positions would inevitably encode this angle in their observations, whether or not they understood the underlying physics. The two golden arcs on the Nebra disk span approximately 82 degrees, which corresponds to the angle between summer solstice sunrise and winter solstice sunset at the disk's latitude, a value directly derived from the 23.5 degree axial tilt. The gates of Gosek frame the same positions. Senenmut's ceiling, with its reverse southern sky, depicts constellations as they would appear from the southern hemisphere, implying knowledge of how the sky changes as you move north or south, which is likewise a consequence of the Earth's axial tilt. 3 artifacts, 3 different cultures, 3 different millennia, all encoding the same geometric relationship between the Earth and the Sun. And then there is the question of heliacal rising. The heliacal rising of a star is the moment when it first becomes visible on the eastern horizon just before dawn, after a period of invisibility while it was too close to the Sun to be seen. Different stars have their heliacal rising at different times of year, depending on their position relative to the Sun's annual path through the zodiac. The ancient Egyptians based their entire calendar on the heliacal rising of Sirius, which coincided with the annual flooding of the Nile and marked the beginning of the agricultural year. The Babylonians tracked the heliacal risings of the planets and the bright zodiacal stars as the basis of their omen literature. The Greeks used the heliacal rising of the Pleiades as a signal for the beginning of the sailing season, and the heliacal rising of Arcturus as a marker for the grape harvest. This is a sophisticated concept. It requires understanding that the Sun moves against the background of the fixed stars, that different stars are visible at different times of year, that the moment of first visibility can be predicted and used as a calendar marker. It is not obvious, it is not intuitive, it requires systematic observation over extended periods, and yet it appears, in one form or another, across all 5 artifacts. The Dendera zodiac encodes the positions of the planets relative to the zodiacal constellations, implying knowledge of their synodic cycles and their heliacal appearances. The decans themselves are essentially a catalogue of heliacal risings, each group of stars marking a 10-day period based on when they first became visible before dawn. The Chinese system recorded in the Dunhuang Atlas organises the sky into lunar mansions and asterisms that were used for similar calendrical purposes. Senenmut's ceiling depicts the planets in their traditional sequences, aligned with decanal stars whose risings and settings governed the Egyptian system of timekeeping. The Nebra disk shows the Pleiades, whose heliacal rising was observed across the ancient world as a seasonal marker. 5 artifacts, 5 cultures, the same underlying concepts, applied in structurally similar ways. The convergence problem is not a problem of coincidence, it is a problem of specificity. If we were dealing with general observations, the sun is bright, the moon changes shape, the stars come out at night, parallel invention would be a perfectly adequate explanation. But we are not dealing with generalities. We are dealing with precise angular measurements, specific asterisms used in equivalent ways, sophisticated cartographic techniques, mathematical relationships between celestial positions that imply accumulated records and systematic methodologies. Where did it come from? Not the observations themselves. Any culture with functioning eyesight can observe the sky, but the framework, the system, the intellectual infrastructure that allowed those observations to be organized into working astronomical models. The conventional answer is that each culture developed its own framework independently, through centuries of trial and error, and that the similarities we see are the natural result of multiple cultures solving the same problem in similar ways. The sky's the same everywhere. The constraints are the same everywhere. Convergent evolution is not just possible but expected. This is a reasonable answer. It is probably the correct answer, in the sense that it does not require us to posit lost civilizations or ancient astronauts or other extraordinary explanations, but it is not a complete answer, because what is missing in every case is the developmental record, the intermediate steps. the centuries of observations that should have accumulated before any of these artifacts could be created. The Egyptians tracked the stars for millennia, but their systematic records, the clay tablets, and observational logs that would show us how they refined their knowledge over time, do not exist in anything like the quantity we would expect. The Chinese maintained astronomical bureaus for centuries, but the working documents that would show us how Li Chunfeng compiled his star catalogue have not survived. The Bronze Age cultures of Central Europe left behind the Nebra disk, but no written records whatsoever, no training manuals, no astronomical treatises, no indication that systematic sky-watching was part of their intellectual tradition. The Neolithic builders of Gossec had no writing at all, and yet they encoded solstice positions with architectural precision that implies generations of accumulated observation. In each case, the artifacts appear more sophisticated than the infrastructure that should have produced them. They imply knowledge without showing us how that knowledge was acquired. They give us the conclusions without the reasoning. It is as if someone handed us a calculus textbook from a culture that left no evidence of having developed arithmetic. What were they all copying from? The question cannot be answered with certainty. Perhaps the developmental records existed and were lost. Paper decays, parchment burns, oral traditions die with their last practitioners. The survival of knowledge across millennia depends on chance as much as intention, and for every document that reaches us from the ancient world, thousands have been destroyed by fire, flood, war, and simple neglect. But the pattern persists, object after object, culture after culture, millennium after millennium. Sophisticated astronomical knowledge appearing in forms that seem to exceed the documented capabilities of the cultures that produced them. Precision that implies instrumentation we cannot find. Accuracy that implies records we cannot trace. Convergences that probability struggles to explain. The stars keep their own counsel. They wheel overhead tonight exactly as they wheeled 6,000 years ago when the builders of Gossec raised their wooden walls, exactly as they wheeled 3,000 years ago when Senenmut's artists painted their ceiling, exactly as they wheeled 1,300 years ago when someone in Tang, China painted his atlas on silk. The cosmos does not explain itself. It simply persists, patient and indifferent, while the civilizations that watched it rise and fall and rise again. And the knowledge, the techniques, the accumulated observations of generations of watchers who studied the sky with care we can barely imagine. Gone, the artifacts remain, the Dendera zodiac in its museum case, the Nebra disk behind its glass, the Gossec circle rebuilt in its original location, the oak poles weathering in the German rain. The Dunhuang Atlas carefully preserved in London, 13 feet of painted silk that somehow survived 11 centuries in a sealed cave before spending another century in a museum drawer. The ceiling of Senenmut's tomb still painted, still intact, still reversed, still depicting stars that its creator could not have seen from where he lived. These are the survivors. These are the fragments that made it through the bottleneck of time, the scattered pages from libraries that burned, the single sentences from books we will never read. They tell us that someone knew. They do not tell us how or why or what became of them. The prosecution has presented its evidence. The case for convergence, for knowledge shared across cultures and centuries in ways that our models of historical development struggle to explain, has been laid out. The same stars, the same angles, the same techniques, the same questions, unanswered. The silence that followed is not the silence of forgetting. It is the silence of deliberate erasure, of catastrophic loss, of transmissions that failed and chains that broke and candles that guttered out in the long darkness between civilizations. But that is the next chapter. For now, stay with the evidence. Stay with these objects, these impossible survivors, these windows into skies that someone watched with more care than we may ever understand. Let the questions settle into your mind without demanding immediate answers. Let the pattern emerge, if there is a pattern. Let the convergences accumulate, if convergence is what we are seeing. The night sky has not changed, the knowledge has. And somewhere in the gap between what the ancients knew and what we can explain lies a story we have not yet learned how to tell. The story we have not yet learned how to tell has, of course, attracted storytellers. Some are careful, some are reckless. Some stand at lecterns in university halls, passing cuneiform tablets with the patience of surgeons. Others sell millions of books proposing civilizations that mainstream archaeology refuses to acknowledge. The gap between what the ancients knew and what we can explain is fertile ground for scholarship, for speculation, for something that hovers uneasily between the two. And if we are honest about the evidence we have just surveyed, we must be honest about the interpretations that evidence has spawned. 3 hypotheses deserve serious examination, not because they are equally credible, they are not, but because each represents a genuine attempt to explain the pattern we have been tracing. Each has advocates who have spent decades developing their arguments. Each has critics who have spent equal energy dismantling them. To understand where we stand at the edge of what can be proved, we must understand what has been proposed and why it remains contested. The first hypothesis is the most controversial, and therefore the one that demands the most careful handling. Graham Hancock was born on the 2nd of August 1950 in Edinburgh, Scotland. He trained as a journalist, worked as an East Africa correspondent for The Economist, and in the early 1990s began publishing books that would make him one of the most famous and most disputed figures in popular archaeology. His central claim, developed across multiple works and refined over 3 decades, is this: that an advanced civilization existed during the last ice age, flourished for millennia, and was destroyed by a catastrophic event approximately 12,900 years ago. The survivors of this civilization, Hancock argues, dispersed across the globe and shared their knowledge with the hunter-gatherer communities they encountered. This, in his model, explains the sudden emergence of sophisticated astronomical knowledge in Egypt, in Sumer, in Mesoamerica, in cultures that should not have possessed it. The catastrophe Hancock proposes is tied to what geologists call the Younger Dryas, a period of abrupt climate change that began around 10900 BCE and lasted roughly 1200 years. The planet, which had been warming as the Ice Age receded, suddenly plunged back into near-glacial conditions. Sea levels rose dramatically as ice sheets melted, coastlines shifted, ecosystems collapsed. The Younger Dryas is real. It is attested in ice cores, in pollen records, in the geological strata of 3 continents. What caused it remains debated. One hypothesis, which Hancock has championed, proposes that comet impacts triggered the cooling. Fragments of a disintegrating comet in this model struck the North American ice sheet, caused massive flooding, threw debris into the atmosphere, and initiated the climate shift that followed. This is the Younger Dryas impact hypothesis. It has supporters among some geologists and planetary scientists. It also has vigorous critics who point to the absence of impact craters of sufficient size, to inconsistent radiocarbon dates that range across 4,000 years for the proposed event, to the lack of iridium anomalies that typically mark extraterrestrial impacts. The debate continues in peer-reviewed journals. It is not settled. But Hancock goes further than the impact hypothesis. He proposes not merely a catastrophe but a civilization, a society sophisticated enough to have developed the astronomical knowledge that later appeared in Egypt and elsewhere, a society that left no cities, no writing, no tools, no graves, nothing except the knowledge it allegedly transmitted to its survivors. This is where mainstream archaeology parts company with him decisively. The objection is not merely that no evidence of such a civilization has been found. The objection is that the claim, as Hancock frames it, is unfalsifiable. A civilization that left no physical trace except transmitted knowledge cannot be disproved by the absence of physical traces. It can only be believed or disbelieved. There is another objection, and it cuts deeper. Archaeologists have argued that Hancock's framework, whatever its intentions, delegitimizes the achievements of indigenous peoples. To propose that sophisticated knowledge in ancient Egypt or Mesoamerica originated with an outside civilization, even a hypothetical lost one, is to imply that the people who built the pyramids, who carved the Mayan calendar, who raised the monuments of the Nile, could not have developed that knowledge themselves. This criticism has been made forcefully and repeatedly. Hancock has disputed it, arguing that he celebrates rather than diminishes ancient achievements. The debate over his work is not merely archaeological. It is political, cultural, and deeply personal to communities whose ancestors built the structures in question. What can be said fairly is this: Graham Hancock has identified a genuine puzzle. The sudden appearance of sophisticated astronomical knowledge in multiple cultures remains unexplained by conventional models of gradual development. His solution to that puzzle, a lost Ice Age civilization, is not supported by physical evidence and is rejected by the overwhelming majority of professional archaeologists. But the puzzle itself does not disappear because his solution is unconvincing. The artifacts remain, the precision remains, the convergences remain. Dismissing Hancock does not explain Gossec or Nebra or Senenmut's sealing. It merely returns us to the silence we started with. The second hypothesis comes from a different direction entirely. Gavin Menzies served for years as a submarine commander in the British Royal Navy before retiring to write books that would prove nearly as controversial as Hancock's. His 2002 work, 421, The Year China Discovered America, proposed that squadrons from the great Ming treasure fleets of Admiral Zheng had reached the Americas between 1421 and 1423, 70 years before Columbus. His 2008 follow-up, 1434, The Year a magnificent Chinese fleet sailed to Italy and ignited the Renaissance, went further still. Menzies claimed that a Ming dynasty fleet reached the Mediterranean around 1434, during the reign of the Zhuan Emperor, and that the astronomical, cartographic and technological knowledge they brought with them sparked the European Renaissance. The implications for our inquiry are obvious. If Chinese fleets were sailing the world's oceans in the 15th century, sharing accumulated astronomical knowledge with every port they visited, the pattern of convergence we have been tracing might have a much simpler explanation than lost civilizations or impossible transmissions. Knowledge travels with trade. Sailors carry star charts. The Dunhuang Atlas, painted in Tang China 8 centuries before Zheng He, could have been the ancestor of navigational documents carried across oceans by later Chinese mariners. The sophistication we see in disparate cultures might reflect not independent development, but a single source, distributed by the most extensive naval expeditions in human history. Menzies presents his case with the confidence of a man who spent his career reading ocean currents and coastlines. He cites maps that he believes show pre-Columbian knowledge of the Americas. He points to artifacts in the New World that he interprets as Chinese in origin. He reconstructs voyages across tens of thousands of miles based on prevailing winds and his own experience as a navigator. The scholarly response has been devastating. Professional historians of China, of navigation, of the Renaissance, have rejected Menzies' claims almost unanimously. The maps he cites have been dated to periods after Columbus. The artifacts he interprets as Chinese have alternative explanations. The voyages he reconstructs require assumptions about fleet movements that contradict Chinese court records. Most fundamentally, critics argue that Menzies' methodology inverts the proper relationship between evidence and conclusion. He begins with a theory, that Chinese fleets circumnavigated the globe, and then interprets ambiguous evidence to support it, rather than following evidence wherever it leads. As one reviewer put it, authors proposing to rewrite centuries of established history should rely on hard evidence rather than subjective claims. This does not mean Zheng He's fleets were insignificant. They were not. The treasure voyages of the early Ming dynasty were genuine marvels. Fleets of hundreds of ships, some over 400 feet long, carrying tens of thousands of sailors across the Indian Ocean to Africa and Arabia. These expeditions are documented in Chinese records. They happened. They represented a peak of maritime capability that Europe would not match for another century. But the evidence that they reached the Americas, or that they sparked the Renaissance, or that they explain the astronomical convergences we have been examining, does not exist in a form that historians find persuasive. Menzies' hypothesis, like Hancock's, points to a real phenomenon, the remarkable maritime capabilities of ancient and medieval civilizations, while proposing an explanation that the evidence does not support, and like Hancock's, its failure does not resolve the underlying puzzle. The Nebra disk was buried 1,000 years before Zheng He was born. Gossec was ancient when the first Chinese dynasty was young. Whatever explains the convergences we have been tracing, it is not 15th century Ming navigation. The third hypothesis is more conservative, more technical, and in some ways more troubling. Otto Neugebauer was born in Austria in 1899 and became one of the 20th century's foremost historians of ancient mathematics and astronomy. His work on Babylonian astronomical texts, cuneiform tablets, recording centuries of careful celestial observation, established beyond doubt that the ancient Near East possessed sophisticated astronomical knowledge far earlier than 19th century scholars had believed. Neugebauer demonstrated that Babylonian astronomers could predict lunar eclipses, track planetary movements, and calculate celestial positions with remarkable accuracy. Their methods were mathematical rather than geometrical, based on arithmetic sequences rather than the trigonometric models that Greeks would later develop. But they worked. Neugebauer's scholarship is foundational. His careful editions of Babylonian astronomical texts remain standard references. His insistence on understanding ancient astronomy on its own terms, not as primitive groping toward modern science, but as a sophisticated system with its own logic and methods, transformed the field. What Neugebauer demonstrated for Babylon raises a question that extends beyond Mesopotamia. If one culture could develop sophisticated astronomical knowledge through sustained observation over centuries, could others? And if that knowledge was transmitted orally from master to student, generation to generation, without written records that survived, would we expect to find the developmental evidence we have been seeking? The hypothesis that might be called long-count oral transmission proposes that astronomical knowledge in pre-literate or partially literate societies was maintained through structured oral traditions, passed down with sufficient fidelity to preserve precise technical information across centuries or millennia. We know that such traditions exist. The Polynesian navigation methods that allowed Pacific Islanders to cross thousands of miles of open ocean were transmitted orally for generations. Aboriginal Australian songlines encode geographical and astronomical information in narrative form. The Vedic hymns of India were preserved through oral recitation for centuries before being written down, with textual accuracy that astonishes modern scholars. Could the astronomical knowledge we see at Gösek, at Nebra, at Senenmut's tomb, represent the surviving traces of oral traditions that maintained precise technical information without leaving documentary evidence? This hypothesis has the virtue of not requiring lost civilizations or globe-spanning voyages. It proposes only that human memory, properly structured, can preserve technical knowledge across generations, something we know to be true. It explains the absence of developmental records by noting that oral traditions, by definition, do not leave written traces. It accounts for convergences by proposing that similar observational methods, applied to the same sky, would produce similar results. But it has problems of its own. The precision we see in these artifacts is extreme. The solstice arcs on the Nebra disk encode angular measurements accurate to within a degree or two. The alignment of Gösek's gates required accuracy that modern surveyors would respect. The Dunhuang Atlas places over 1,300 stars with errors averaging only a few degrees. Oral traditions can preserve remarkable amounts of information, but they tend to introduce drift over time. Errors accumulate, details shift. The fidelity required to maintain the precision we observe over centuries without written verification, without instruments we can identify, strains the model. And there is another problem, more fundamental still. The hypothesis of oral transmission explains how knowledge might have been preserved without leaving traces. It does not explain how that knowledge was acquired in the first place. Someone at some point had to make the observations, someone had to develop the methods, someone had to build the instruments, or their equivalents, that allowed angular measurements of the precision we observe. The oral transmission model pushes the mystery back in time, it does not solve it. 3 hypotheses, 3 serious attempts to explain the pattern, none fully successful. Hancock proposes a lost civilization that left no trace except transmitted knowledge, a claim that cannot be proved and, crucially, cannot be disproved. Menzies proposes global voyages that the documentary evidence does not support. The oral transmission model explains preservation, without explaining acquisition, and strains against the precision the artifacts display. This is where scholarship stands. Not at an answer, but at a boundary. The evidence takes us to a cliff edge, and the hypotheses we have constructed are bridges that do not quite reach the other side. We can see that something lies beyond the gap. We cannot cross to it. Perhaps this is the nature of the problem. Perhaps some questions about the deep past are not soluble with the evidence that survives. We are not archaeologists with trowels and brushes, able to excavate new evidence that might settle the debate. We are observers, reviewing what has already been found, tracing patterns in fragments that may never cohere into a complete picture. The artifacts tell us that someone knew. They do not tell us how they came to know it. And the gap between those two facts may be permanent. But there is something else the artifacts tell us. Something we have not yet fully confronted. They stopped. The Dendera zodiac hangs in the Louvre, room 12 bis of the Sully Wing, Egyptian Antiquities ground floor. The circular sandstone disc, 8 feet across, has been mounted vertically behind glass, lit by museum spots that pick out the carved figures of the zodiac signs, the 36 deacons, the 5 visible planets arrayed along the ecliptic. Tourists pass it daily. Most do not know what they're seeing. A complete map of the ancient sky, sophisticated enough to encode specific eclipse dates, precise enough to let modern astronomers identify the exact month it depicts. 51 BCE, March, a solar eclipse over Egypt. The temple complex at Dendera still stands. The ceiling from which the zodiac was cut has been filled with a plaster replica. The site is open to visitors. Guides explain the architecture, the rituals, the goddess Hathor to whom the temple was dedicated. But no one at Dendera today can read the zodiac the way its creators did. No Egyptian priest practices the decanal observations that structured the ancient year. No student learns the methods that placed those stars in those positions with that precision. The knowledge ended. The tradition broke. What survives is the object, not the understanding. The Nebra sky disk rests in the State Museum of Prehistory in Halle, in the German state of Saxony-Anhalt. Climate-controlled, behind protective glass, rotated periodically to manage light exposure. The bronze has patinated green over 36 centuries. The gold inlays, sun or moon, crescent, the 7 stars of the Pleiades, the twin arcs marking solstice angles, still gleam against the oxidized metal. It is classified as part of UNESCO's Memory of the World program, one of the most important archaeological discoveries of the 20th century. But no one from the Unitic culture survived to explain it. No descendant of the Bronze Age astronomers who measured solstice angles on that German hilltop left instructions for their students. The disk was buried, around 1600 BCE, in a cache with weapons and tools. Was it hidden for safekeeping, deposited as an offering, discarded when its purpose was forgotten? We do not know. The burial ended the disk's active use. The knowledge it encoded did not continue. For 35 centuries, the sky it depicted kept turning, and no one in Central Europe remembered how to read it. The Gossec Circle stands in an empty field in Saxony-Anhalt, not far from where the Nebra disk was found. The original timber posts rotted away millennia ago. What visitors see today is a reconstruction. Oak poles driven into the earth in the pattern, revealed by aerial photography in 1991 and confirmed by excavation in 2002. The gates face the sunrise on the winter solstice, southeast and southwest, and a third gate faces due north. Standing at the centre on the shortest day of the year, an observer would see the sun rise through the southeastern gate and set through the southwestern one. The alignment is precise, the intention is unmistakable. But the builders of Gossec left no written records. No successor culture at that site maintained the observations. The circle was used for perhaps 2 or 3 centuries around 4900 BCE, then abandoned. The timbers fell, the ditches silted in. The fields were ploughed for 49 centuries before anyone noticed the crop marks that revealed the circle's existence. The oldest astronomical observatory in Europe, older than Stonehenge by a millennium. And we know almost nothing about who built it, what rituals they performed there, or why they stopped. The Dunhuang Star Atlas lies in the collection of the British Library. 13 feet of painted silk rolled carefully in a climate-controlled drawer, unrolled only for conservation assessments and rare scholarly examinations. 1,339 stars organised into 12 panels following the hour-angle system, plus 1 circumpolar panel for the stars that never set. A quasi-cylindrical projection that anticipated European cartographic methods by 8 centuries. The oldest complete star atlas from any civilization. It was found in 1907 by the Hungarian-British archaeologist Aurel Stein in Cave 17 of the Mogao Grottos near Dunhuang, a sealed library cave that had been closed around 1002 CE and not opened for 900 years. When Stein purchased it, along with thousands of other manuscripts, the knowledge it encoded had been lost for centuries. Chinese astronomy continued, of course. The imperial courts maintained astronomical bureaus. Star maps were drawn and redrawn. But the specific methods used to create the Dunhuang Atlas, the projection system, the observation techniques, the mathematical models that placed those stars with that accuracy, those were not passed down. The atlas preserved them. Chinese tradition did not. And then there is Senenmut's sealing. Tomb TT 353 lies beneath the cliffs of Deir el-Bahri, in the shadow of the mortuary temple that Senenmut himself helped design for his queen, Hatshepsut. The tomb was never finished. The burial chamber was never completed. Senenmut's sarcophagus was found smashed, his mummy never located. His monuments were defaced after Hatshepsut's death. His name chiselled from the walls, his images destroyed, but the ceiling of his tomb survived. In a small chamber painted in the 15th century BCE, the oldest astronomical ceiling in Egypt remains intact. The northern and southern panels, the constellations, the decans, the stars that move the wrong direction, the stars that should not be visible from that latitude. The tomb is rarely visited. It is not on the standard tourist routes. Access requires special permission. The chambers are small, the air close, the preservation concern significant. Most people who are interested in Senenmut's ceiling see photographs, reproductions, scholarly diagrams. The original remains in darkness, as it has for 34 centuries, depicting a sky that its creator could not have fully observed from where he lived. What these objects share is not just sophistication, it is finality. Each appeared fully formed. Each functioned as a precision instrument, a calendar, a map, an observatory, a teaching device. Each demonstrates knowledge that implies generations of prior observation, systematic methods, accumulated expertise. And each stopped. No school continued the tradition. No students carried the methods forward. No successor culture maintained the observations. This is not the normal pattern of technological development. When a useful technique is discovered, it spreads. It is copied, adapted, improved, transmitted to neighbours and descendants. The wheel did not appear once and vanish. Bronzeworking did not emerge fully formed and then disappear. Writing, once invented, persisted and proliferated. The technologies that work endure. But astronomical knowledge of this precision, the kind of knowledge that requires decades of observation to develop, generations of transmission to preserve, institutions of some kind to maintain, this knowledge, in case after case, appeared and then ended. Not gradually, not through slow decline, it simply stopped being transmitted. Why? The Younger Dryas, which Hancock invokes, was a real catastrophe. Sea levels rose, coastlines changed, populations were disrupted. Could climate change have broken chains of transmission that had previously maintained astronomical knowledge? Perhaps. The period around 10,900 BCE does mark a discontinuity in human development, but Gösek was built 4,000 years after the Younger Dryas ended. Senenmut painted his ceiling 8,000 years later. The Dunhuang Atlas was created in a period of relative stability in Tang China. Climate catastrophe does not explain all the breaks. Disease could explain some of them. A plague that killed specialists, masters who had not yet trained successors, could end a tradition in a single generation. We know this happened with other technologies. Techniques for making certain kinds of Roman concrete were lost when the craftsmen who knew them died without teaching others. The formula for Greek fire, the Byzantine weapon, was so closely guarded that it vanished when its keepers did. Specialized knowledge is fragile. It exists in human minds, and when those minds die, it dies with them. War and conquest could explain others. Cultures that are conquered often lose their technical traditions, sometimes because the conquerors actively suppress them, sometimes simply because the institutions that maintained them are destroyed. Senenmut's monuments were defaced after Hatshepsut's death. His tomb was violated, his body lost. Did the political upheaval that erased his memory also erase the astronomical traditions he had represented? We cannot know. The records that would tell us do not exist. But there is another possibility, more unsettling than any of these. What if the breaks in transmission were not accidental? What if the knowledge was deliberately restricted, limited to a small group of specialists who chose not to share it widely? Priesthoods in many cultures have maintained secret knowledge. Technical guilds have guarded trade secrets. The astronomical knowledge we see in these artifacts may have been the property of closed communities that passed it from master to student in unbroken chains, chains that could be broken by a single failure of succession, a single moment when no qualified student was available to receive the teaching. If this is what happened, the loss was built into the system. Knowledge that is hoarded is knowledge that is vulnerable. Every generation of transmission is a bottleneck. Every master who dies without a student is a break in the chain. The very secrecy that made the knowledge valuable made it fragile. We will never know for certain. The evidence does not exist. What we have are the objects themselves, silent, precise, inexplicable, and the silence that followed them. The Dendera zodiac has hung in the Louvre for 2 centuries. Scholars have studied it, dated it, decoded its eclipse markers and planetary positions. But no one today practices the decanal astronomy it depicts. The tradition it represents is extinct. What we have is the shell, not the living system. The Nebra disk lay buried in a German hillside for 36 centuries. When it was dug up by treasure hunters in 1999, it was extracted so carelessly that the archaeological context was destroyed. We cannot say with certainty how it was used, by whom, for what purpose. We can only describe what it depicts. The knowledge it represented was gone millennia before it was rediscovered. The Gossec Circle was built, used, and abandoned before writing existed in that part of the world. Its builders left no testimony. Their successors left no records. The reconstructed timber posts that stand on the site today are a physical memory of something that vanished completely from human consciousness until aerial photographs revealed the crop marks that proved it had existed. The Dunhuang Atlas survived by accident, sealed in a cave for 9 centuries, rediscovered by a foreign archaeologist, purchased and shipped to London. The Chinese astronomical tradition continued, but not in the specific form the atlas represents. What the atlas preserves is a snapshot of a system that was already changing when the silk was painted, a moment frozen in pigment while the living practice moved on and eventually forgot the methods the atlas documented. And Senenmut's ceiling remains in his unfinished tomb, depicting a sky that reverses the natural order, showing stars that could not be observed from his latitude, encoding knowledge that his own culture did not explain and did not pass down. These are the survivors, not because they were the best or the most important or the most accurate. They survived because chance preserved them while everything around them was destroyed. For every object that reached us, thousands were lost. For every tradition fragmentarily documented, dozens vanished without a trace. We are seeing the wreckage, not the fleet. We are reading the fragments, not the library. And so we return to the beginning, to the question that opened this inquiry. What were they all looking at? What were they all copying from? The answer, if there is an answer, lies in the gap between the artifacts and the silence that surrounds them. Someone knew. Someone observed the sky with patience and precision we can barely imagine, tracked the movements of stars across years and decades and generations, developed methods for recording their positions, built instruments for measuring their angles, created systems for transmitting their knowledge. All of this happened. The evidence is in front of us, carved in stone, inlaid in bronze, painted on silk, aligned in timber. And then it stopped. Not everywhere at once, not for the same reasons. But again and again, in culture after culture, millennium after millennium, the chain broke. The teaching ended. The knowledge passed out of human possession. The night sky remains. The stars that Senenmut depicted still rise over Thebes, still trace their ancient paths across the heavens. The Pleiades that appear on the Nebra disk still mark the turning of the seasons, still set in the western sky as winter approaches, still rise before dawn in late spring to announce that the cycle has begun again. The solstice still arrives with metronomic precision, the sun reaching its extreme positions exactly when Gossec's gates predict it will, exactly when the arcs on the Nebra disk indicate it should. The cosmos has not changed. The observers have. We stand at the end of a chain that began before writing, before cities, before history as we understand it. Fragments have reached us, beautiful fragments, precise fragments, fragments that imply a picture we can never fully reconstruct. We know that someone watched, we know that someone understood, we know that the knowledge they accumulated was real, because the objects they left us work. The predictions they made were accurate, the measurements they took were correct, but the watchers are gone. The understanding is gone. The thread that connected their knowledge to ours has been severed so many times in so many places that we cannot trace it back to its source. This is the long silence, not the absence of knowledge. The knowledge existed, not the failure of observation. The observations were made. The long silence is what happened after. The centuries when the temple stood empty and no one remembered how to read the ceiling. The millennia when the disk lay buried and no one above knew what it had measured. The generations when the timber rotted and the ditches filled and the memory of what had happened there passed entirely out of human awareness. The knowledge was real. It worked. Someone held it. And now, by every measure we have, by every trace we can find, by every test we can apply, it is gone. The night is vast and the stars are many. They have watched civilizations rise and fall and rise again. They will watch ours in time join the pattern. What we know, what we have learned, what we have built with such care over centuries of observation, all of it is as fragile as the silk of the Dunhuang Atlas, as vulnerable as the timber of Gossec, as easily lost as the methods that painted Senenmut's reversed sky. We are not the first to watch. We will not be the last. And someday, perhaps, scholars we will never meet will study the fragments we leave behind and wonder what we knew, and how we knew it, and what happened to the knowledge when we were gone. The stars keep no records. They simply shine, patient and indifferent, while the watchers come and go beneath them, and the silence, in the end, is the only answer they give.